All right, 2013, number 6. Here is a Taylor polynomial one, series 1. So a function f has derivatives of all orders at x equals 0. So this is really a Maclaurin series because at x equals 0, right? Let p sub n of x denote the nth degree Taylor polynomial for about f at x equals 0. All right, so now, before I do anything else, I'm going to write out my Taylor polynomial, right? Because it's at x equals 0, this is really a Maclaurin. So it would really be f of 0 plus the first derivative at 0 times x minus 0, which is just x, plus the second derivative at 0 over 2 factorial times, again, x minus 0 is just x, so it would be x squared, plus the third derivative at 0 over 3 factorial times x cubed plus dot, dot, dot. So that's the general series, right? So knowing this helps, especially when you have to put it together. So now let's do A. It is known that f of 0 equals -4 and that p sub 1 of a half is -3. Show that the first derivative at 0 equals 2. So that means I'm looking at this part right here, right? So let's see. So p sub 1, that means it is a first degree Taylor polynomial. That means I'm only going to the first derivative. So f of 0 plus the first derivative at 0 times x. I know from this part right here that at f of 0, this is -4, right? I also know that when x is a half, the answer equals -3. So that means -3 plus, I don't know the first derivative at 0, but I know x is a half. So now we're just doing some algebra, right? I'm going to add 4 to both sides. So adding 4, that makes this 1 equals the first derivative at 0 times a half. Multiply by a half. I get 2 equals the first derivative at 0, which is what I had to show. Check. So their big thing, this is 2 points. 1 point for recognizing that you had to do this, and a point for showing all the work to lead to that. All right, part B. All right, part B. Oops, here we go, get a pen. B, it is known that the second derivative at 0 is -2/3, and the third derivative at 0 is 1/3. Find p sub 3 of x. So I'm using now what I had written before. Remember that this is f of 0 plus the first derivative at 0 times x plus the second derivative at 0 over 2 factorial times x squared plus the third derivative at 0 over 3 factorial times x cubed. I'm stopping here. Why am I stopping here? Because it said p sub 3, right? That means it's a third degree. So that means I have to go all the way to the third derivative. So p sub 3 of x is, now plug everything in using the information we have from part A as well. We know f of 0 is -4 plus the first derivative we already proved, but even if we didn't prove it correctly in part A, you can still do B because they told you what it was in part A. Got it? So even if you didn't understand how part A, whatever part A was, if you could do B just by plugging in now, knowing that that is 2 times x, plus the second derivative at 0, that's going to be -2/3 x squared, don't forget our 2 factorial, plus the third derivative at 0 is going to be 1/3. I still have x cubed over 3 factorial. So if I simplify this, I get -4 plus 2x minus x squared over 3, because this 2 would cancel out with one of those 2's, plus x cubed over 3 factorial is 6. 6 times 3 is 18. And there you go. You got 3 points for this. 1 point for the first two terms because it was kind of already used. 1 point for the third term, 1 point for the fourth term. Oh, this is squared, by the way, not cubed. My bad. X squared, x cubed. There you go. All right, part C. The function h has a first derivative by the derivative h of x is f of 2x. It is known that h of 0 is 7. Find the third degree Taylor polynomial for h about x equals 0. Okay. So, how are we going to do that? Well, you could be plugging stuff in again, you know, okay. This is going to be f of 0 plus the first derivative at 0 times x plus the second derivative at 0 over 2 factorial times x squared plus the third derivative at 0 over 3 factorial times x cubed. Stopping here because it is a third degree. Correct? Now, what was f of x? You might need to remember the stuff from f of x, which is fine, we will. So, first off, h of 0, let's see, I don't know, we can use any letter. I'm going to say t. This is t third of x. So, h of 0 equals 7. So, the first thing is 7. Perfect. Got it? Plus the first derivative. Well, the first derivative of h of x is f of 2x. Well, what does that mean? Well, let's see. F of x was negative 4 plus 2x. So if I do f of 2x, that's going to be negative 4 plus 2 instead of x. That would be 2x, which then becomes negative 4 plus 4x. Wait, I have to add more. So negative 4 plus 2x minus 1/3 x squared plus 1/18 x cubed. That was our f of x. So that becomes minus 1/3 2x squared plus 18th 2x cubed. So then this becomes minus 4/3 x squared plus 8 over 18 reduces to 4/9 x cubed. Okay. But that's just the first derivative of h of x. Right? So if I have to do the second derivative of h of x, okay, I forgot, we're doing h of 0, so I have to plug in x equals 0. So this would be gone, this would be gone, that would be gone, so you just have negative 4. But with the x, so this becomes negative 4x. So next, the derivative of negative 8/3, and then 3 comes down, that 3 cancels out, so 4/3. So if I take the second derivative of h of x, that's really with a chain rule 2 times the first derivative of 2x, which we'd have to put back in. I'm going to put the bottom here. So far we've got t cubed of x equals negative 7 minus 4x. So now I did the second derivative, or the derivative of fx. So it's going to be 2 times the derivative of f of 2x, right? So we take the derivative again, so you get 2 times 4 minus 8/3 x squared but you're plugging in 2x, so you get 2 times 4 minus 8/3 of 2x plus 4/3 2x. Actually not, because we already put the 2x was in there from the previous problem. But now I'm going to do it where, all right, x equals 0. So that x goes away, that goes away. So 2 times 4 would just be 8. So then I'd get, this would be the second derivative, right? So that would be plus 8 over 2 factorial x squared. Yeah, this problem really sucks. I'm sorry. All right, hopefully you don't get something like this. So the third derivative is the last time you got to take the derivative. So when we take the derivative, chain rule again, so the 2 comes out, that'd be 4. And then the second derivative of 2x. So I would have a 4 and the derivative of this. Well, derivative of 4 goes, the derivative of negative 8/3 x would be just negative 8/3 plus the 2 comes down, it's going to be 8 over 3 x, and again we're plugging in x equals 0, so that goes away. And so 4 times negative 8/3. So 4 times negative 8 is going to be 32. So negative 32/3. So that becomes minus 32 over 3 x cubed over 3 factorial. I'm not sure if this is right. I'll be really, really honest with you. Let me get back to you on that. But that's how I'm seeing that we have to do C. All right. Hope that kind of helps. A and B you guys should be able to do. C is the tough one. All right. Let me know if you guys need anything else. Bye.